So, I was at OOPSLA for the first time 25 years ago, so it's nice to be here again. Believe it or not, I've spent the last 29 years implementing and designing object-oriented systems. So, and most of the inspiration I've gotten from you guys here. So it's just amazing to see how the whole object-oriented community has grown and become successful. And I believe it's for two reasons. Object-oriented programs are just easier to understand for programmers. They bind data and behavior into the same unit. And secondly, because I've been working on virtual machines for so many years, I think that also all the advances in virtual machine technology has helped make them very performant. So today I'll be talking about what I've been working on the last 5 years. This is the Dart programming language. And I'll try to relate a little bit to where we got the ideas from. And I hope you'll like that. First of all, before I go on with the presentation, I want to say that it's important to innovate within programming languages. Please make more of them. The market and the communities will make sure they filter the bad ones out so the good ones can survive, and that will in turn make you all better programmers. So Dart is another attempt to try to innovate a little bit in one area, and I hope you can see why. Before I start about what Dart is, I'll just go a little bit back so you can see some of my background and see why we made the decision we did when designing Dart. I've had a few systems I worked on. The first one is Beta. I assume most of you know about Beta. Can I get a hand up if somebody knows about Beta? Great. Great community. I think that Beta was novel, successor of Similar 67, based on patterns, and they were both virtual and nested, and they used inner instead of super, so the control went from the super pattern to the sub pattern, so on, and they had a left to right control flow in the statements. It was created in Scandinavia by Bent Brun Christensen, Ole Lehmann Madsen, Biver Møller, and Christian Nygaard. Ole Lehmann was my professor at the university when I studied there, and it certainly had an influence on me. The uniformity was great, but it's hard to learn. And I think that's certainly a lesson I've learned, that if you introduce a new programming language, it has to be sort of digestible by normal programmers. One of the problems with Beta was the syntax. Another one was the uniformity. When you looked at a pattern, you actually didn't know if you use it as a function or as a class or as a closure. And I think that created some confusion. Anyways, I learned how to do models in Beta, and I think that had helped me organize programs in a better oriented way since. I then went to the self-system, which was a very interesting project. It was a successor to Smalltalk, where they focused on boiling down the programming language to an essential simple model. The problem was it looked like it was extremely inefficient. But many of the compilation ideas from the research project was actually very novel. Adaptive compilation and also de-optimization you all have read about. And that has inspired me in most of the systems I built since, because it's just very good ideas. One problem I can see with Self is that it's prototype-based. I don't know how many of you have programmed in prototype-based languages. Amazing. This is my personal opinion. I think it's just hard to program with prototypes. There's two problems with them I can see. That when you want to create a clone of something, it works fine if it's a very simple data structure, but if it's a more complex one like a dictionary, it's very hard to clone without using reflection. The second one is that you often pollute the prototype if it's not only. So if you pollute the prototype and make clones of it, then you start destroying the program behavior. So what I saw when working in the self team and saw the programmers using it, they started using class-based programming, where they constructed the objects from scratch each and every time they created a new structure. And so that was not the idea behind it. So that was some of the problems in the self system, and I guess also in other systems. But out of the self project came very interesting compilation ideas. And we did a startup called Anamorphic Systems in '94, where we tried to make a high-performant virtual machine for Smalltalk, and also added some language extension to Smalltalk, a type system which was optional. The language was created by David Griswold and Lars Bak, which is here today. And that was a really cool system until they announced that Java was going to take over the world. So we changed that technology behind the Strongtalk system and converted it to using Java bytecodes, and that became the Hotspot VM. To Sun Micro 97. And there's something wrong. Okay. Okay. Sorry about that. Can you hear me now? Greatness. Okay, this is complicated. I'm back again. So it got acquired by Sun Microsystem. I spent many years tuning the Hotspot VM, so it'll be fast. And one thing I learned from this system, and many learned, is that even though that Java was originally fairly slow compared to other language systems, you can actually make it really fast by using novel compilation techniques. And in Hotspot, we applied the same techniques as we did in the self system, where we used adaptive compilations and also de-optimization. It gave you two things. One is that you could, based on the behavior of the program, do inlining and make it run really fast. You can break down abstraction boundaries inside the compiler. The second one was de-optimization, which meant that you can still, in production, debug the code as if you are sitting in debug mode. So you didn't really care whether you ran on a Sun machine or an HP machine. You can connect to it in production, and you could debug it as if you were in debug mode. So, and I believe that the Hotspot VM propelled the acceptance of Java in the industry. So that was nice to see. For many companies, Java meant that you could actually have a heterogeneous machine park, which was pretty awesome. So instead of previously, you could only have one kind of machines in your server park. Now you could mix and match different machines, but still run the same program on all of them. And that was enabled by virtual machine technology. I did a few systems in between, but in 2006, I got hired in at Google to do a fast JavaScript engine to run fast. As you probably know, that many of the services we have at Google, they're based on the browser. So it was important that JavaScript was fast. And so that was the first time I looked at JavaScript, which is a scripting language for the web created by Brendan Eich. And it was intriguing to me because it was unlike any programming language I've ever seen. It was very dynamic. You could patch libraries on the fly and whatnot. And it was puzzling because how would you ever make this program run really fast, written in JavaScript? Luckily, we found a way to use some of the techniques developed in Self and also in Hotspot to apply to this very dynamic programming language by putting in dependencies at runtime, so that if they're violated, we could flush the code and start over again. So it was a code generation on steroids, V8 for Chrome. But this was the inspiration for Dart, basically. We looked at JavaScript, we looked at how programs got bigger and bigger for the web, and we saw that JavaScript might not be the ideal for writing big programs for the web. So we got inspired by JavaScript for that. One thing I have to say public here is that I'm not against JavaScript as a programmer. It's fine. The more, the merrier. But we also have to recognize that if people are doing big programs for the web, they need good tools to write them in. The cost of having a lot of programmers is just high, and if you can reduce that cost, it will be good for everybody. So here's some of the issues with JavaScript, and if you object, you should stand up. We can take a small discussion. I think readability is very important for programs. To me, JavaScript is just hard to read. There's no declarative syntax. The program you get when you read in a JavaScript program is constructed as you read it in. It's really hard to find dependencies between the different program segments. And then many of the libraries you read in, they do monkey patching of existing library objects. And I think that makes it really hard unless you are a very skilled programmer to understand what's going on. For me, readability of programs is super important because it helps programmer productivity. Right? You can get a new programmer into your team and they can start looking at the code and understand what's going on, and then they can be productive fairly quickly. And also, when you do debugging, you can actually relate to what you see in the debugger to what you have in your source code. I think that's important. Second one is that JavaScript has been designed to handle errors in a special way, and we call it the keep on trucking semantics. And it means that if you do a spelling error on one of the property names, the system will just continue. Like if you try to access the wrong property, an object works like a dictionary, and you just get undefined back again, it will continue. And some people like that, I don't. Also, JavaScript is not a pure object-oriented programming language. That means that some of the core values of the system are present as non-objects but as values, and they are converted between each other on the fly. That means that sometimes often you can compare a Boolean to an integer to, not an integer, a number to a string, and it will all work out automatically. I think that's confusing, especially when you're debugging. You cannot see what you actually have in your program. So, in my mind, throwing errors early would make it easier to recognize the problem and correct it, like spelling errors. And also, it gives you confidence in the deployed app when you tested it. Scalability is important when you write big programs. You want to build libraries that are robust, people can use and reuse. In JavaScript, it's very hard because you monkey patch code and read in segments that are overlapping. And code can change on the fly. If you want to change the push and pop operations on an array on the fly, you can do that. Don't swap them because it creates problems. So what happens in most companies is in order to have some sort of discipline when writing big programs in JavaScript, they have to enforce certain rules. Often they come up with comments that have sort of pseudotypes in them, so that you can have tools that will check on top of these big programs whether you use JavaScript in a reasonable way. In fact, they try to use JavaScript as an assembly language. I have to say that JavaScript has evolved since, but this is at the time where we decided to use Dart. Now they have, at least in the new versions of JavaScript, put in classes and all kinds of stuff. But you can still patch code, and it's pretty interesting. So, Dart. So we got inspired by this. We should be able to do it better. We looked around, and of course there was other projects that were translating code to JavaScript. We had a grid from Google that translated a subset of Java to JavaScript, and also CoffeeScript and so on. But we wanted to go a bit further. We wanted to make something that was much more suitable for the web browser. One thing we really liked about JavaScript, I have to say that, is that there was no tools in your way. You could look at a web page, look at the JavaScript, change the code, and reload, and you are running again. That meant that any person with a little bit of technical insight could be a programmer. And I think that's very powerful. And we sometimes miss that as professionals, in that we create complicated type systems and complicated tools, and unless it passes through all these tools, you cannot run the program. And I think that's a big turnoff for many programmers, especially the uneducated ones. So we wanted something that was very easy to use as well, and that was the starting point of Dart. Programming languages, to me, are interesting because it's not only about having the theory behind the program is correct. People have to like it. They have to like it, the programmers. They have to use it, and it has to be productive. So when they do a big project, they have to see the benefits. And at the end, it also has to be performant. So all of that has to be there, otherwise people will not use it. In the old days, like when I did beta and whatnot 30 years ago, it was enough to write a spec and a small interpreter, and people got excited about a programming language. We are past that. It has to be performant, otherwise people will not use it, and there has to be tools and libraries around it. So it's a huge investment to start a new programming language these days. So what is it you need to do when you want to improve programmer productivity? I think you need a simple and clear language semantics. It has to be scalable so you can write big programs, and you need libraries that are composable. And then you need fast development cycles. I've talked to a lot of programmers that write big programs, and they get into this mode if the tools are in the way. If it takes 30 seconds to compile their 200,000 line program, they go out and get coffee and go back again, and they become extremely unproductive. You can change that game if you, within half a second, can start up the program again. And it also changes their way of working, because then they start doing experimentation because there's no much cost to doing it. So getting the tools out of the way is super important to get program productivity up. And then you also need fast startup and good performance, but everybody knows that. And then you need tool support. Tool support is important because you want to do refactoring, and you want to make sure that younger or new, we get sound. When you get new team members onto your team, they can start navigating the code and understand how it's connected. So all of this you have to do to improve programmer productivity. Now, when designing Dart, we knew we had to get Dart running inside the browser. And this is how I felt the first year. There was a lot of stuff we couldn't do because of the restrictions of the browser. We didn't want to just make a new VM and dump it into Chrome and say you could only write Dart programs if you ran Chrome. It had to run on all browsers. So one of the top goals was to make sure that it could translate efficiently into JavaScript. And it also had to support web browsers across the board and the DOM. So you probably all know web browsers. They're not the ideal execution platform. It's single-threaded. If you do computation that takes more than a few seconds, you will be stopped and stuff like that. So doing general-purpose programming in the browser is just hard. It also has to be secure, because security is really important when the normal user of the browser can just download new code. So we cannot compromise the security of the underlying system. And then it must be easy to learn, and that's where the curly braces come in. From beta and And certainly self, I learned that people they don't want to take big steps when it comes to syntax. And that's just sad, but that's how it is. If they have seen the curly braces before, they have an easier time picking it up again. But that's just how it is. So people sometimes claim that new languages are sort of created over a weekend, over 2 weeks, and stuff like that. That is not the case with Dart. We actually spend a lot of time making it right in our minds. Probably agree with me. Some will not agree with me that it's a good programming language, but hopefully you can see we have spent some time getting it consistent in most parts. We started with a program language called Spot. I did with Kasper Lund, and we implemented a virtual machine for it and ran it. And we just did that in 1 quarter, which is 3 months, to make sure that we had a good starting point. And we evaluated the program language, threw it out, and that was the starting point for the Dart language design. Kasper and me are virtual machine programmers, and we know how to make stuff fast. We are not language designers, so that's where Gilad comes in. We hired him fairly early in the process to make sure that we could early on write a consistent spec and get the details right before we sent it out to the world. And it was a long, complicated process where while we designed the programming language, we always implemented it in a virtual machine and also updated the translator to JavaScript. And we had a lot of iterations where we improved the design and evaluated until it was consistent and fast enough. So there was features like we would have liked to have in, for instance, like non-local returns from Smalltalk, because that's a nice way of terminating a recursion. But you could not do that in JavaScript because you had to translate it into exceptions throwing, and that was just extremely slow. So stuff like that we had to sort of cut from the language. So here it is. Most of the stuff we have in Dart is borrowed. It's an unsurprising, simple object-oriented programming language, and we have really, really tried to make it simple. So it's single inheritance. We have interfaces. We have mixins. We have lexical scoping. Surprise to some, but we have that. It's single-threaded, mostly because of the browser restriction. But we have some isolate-based concurrency, so we can spin off new isolates and communicate with them. And then we have the optional static type system, which so some of you are familiar from the StrongTop work. So Dart is just this combination of interesting ideas from other places and melded into one programming language. The syntax we wanted to have is similar to JavaScript and Java, so people could actually be productive in Dart within 2 hours if they could do programming. That was the goal. So here it is, the programming language. You've probably seen a point before, so this is a point. We have a class with a constructor, and an operator plus returns a new point, and a two-string operation that's using string interpolation to return a string that describes the point. And we have a main function. It makes a point, and it prints the result of adding 2 points. Not very exciting, but that's how it looks. And the point is that all of you should be able to recognize this right away, even though you have never seen Dart before. Static types in Dart. This is an interesting one. Gilad has been here at OOPSLA to talk about our static type system. I'll not go into the details of it. I'll just mention why we did it and a few examples. So one thing we learned from StrongTalk is that there's something really appealing to having mixed mode code. Some code that's untyped and some code that's typed. The untyped code is great for experimentation. Then the type checker is not in your way. But as you mature the code, it's great to put in types because that states the intent of the program in my mind. So you saw the green var before in the first example. The way we add types to Dart is to replace that with the green stuff here. So you can say that the point has two numbers now, and the plus operator returns point, and so forth. But it still looks like motherhood and apple pie to most. The way it works is that the virtual machine can run the program without the types, or with the types, it will do exactly the same. So the types we have in Dart are only used for the static tools we have. You don't have to use the static tools. So the way we see it is these type annotations are mostly to convey program intent. It's basically, instead of, I talked about before, that companies did comments with types in them to check the program. We have it here inside the programming language, so it acts as checkable documentation. We've added generics as well. They are unsound, and people get mad about that, but it's not a big deal because we have mixed mode code. We always have code that's not checked or not annotated with static types, and some with static types. So that's just how it is. And in reality, we have not seen a big problem with it. People actually like the types we have. They're very simple to use. The reason why we have made these simple generic types we have is that we have seen how people have a hard time coping with generics in Java. I hope you can agree with me. It's not for the entry-level programmer to make classes with generics in Java. It's complicated. And so we'll try to make that simple. And the only thing you get out of it is basically, if you, in Java terms, is you put in implicit cast that you cannot see in the code. That's it. So people talk about Java has a sound type system, and so that's fine. But as soon as you put in a cast, it's sort of gone, because that can flunk at runtime. All right. So the point is that all these type annotations can be removed from the code, and you just run exactly the same way. And it has no impact on performance because the types we have in Dart, they're interface types, so they cannot be used to determine whether we have a certain kind of object at a certain place. So we've seen two ways people are using this mixed mode code in Dart. One is they are gradually hardening the program with types. So they find it more efficient to do experimentation without types, and as you go along, you put in the static types. And they're great for communicating intent between team members and between libraries. And then we have companies that have different kinds of programmers, right? They have designers sitting in a group doing more of the UI and whatnot, and then you have engineers doing the communication to the back end. And the engineers, they like writing fully typed code, and the designers, they hate it. So what they do in Dart is the designers use untyped code, and then the engineers take their code and run it in check mode, so they can make sure that all objects passed into the statically strongly code will be validated when they do unit testing and whatnot. So here's a little bit longer example. It's a histogram. It's a generic histogram. It takes the key type and the value type K and V, and it has a result and a sorted list, has constructor. Constructor takes a get key from the value, and then it has an iterable with the values. And it does this computation, sorting and whatnot, and you can dump it at the end. The point is not to understand the code. The point is to see how we use a strongly typed class in different settings. So the first uses I want to show you is we have a main program here, and you have a list. It's just an array. And you can create a new histogram, and you pass in the identity function and the list, and you say .dump. And it prints out the sorted histogram, which is great. So you can see here that we are not using any type annotations when creating a new histogram, and it just works. So that's one way. You have code here that's untyped, that's using typed libraries. It's very common usage. What you can do is you can, of course, when you make an instance of a histogram, provide the type parameters. In this case here, key and value will be strings. And you do it again. If you run that in our system while you're doing debugging, you get a check mode execution error. It says that you cannot use an int where you should have used a string. So it'll be a runtime check. So this is one way. You still have the list is untyped. The histogram is typed, and therefore there'll be a runtime check when you violate the contract. If you tighten it up further, you put in the types for the list, and then you get the type error before running the program if you use our type checker. So that's 3 different ways you can use a histogram in our setting, and it shows you how early you get the error if there's an error. It seems like the programmers that have been using Dart are okay with this, where you have different ways of getting errors. Some teams prefer type checking all the code all the time, which is fine. So they just have this convention that you can only check in code that's fully typed. And that's fine with us. We don't have a problem with that. But it's basically up to the organization to define what they want to do. We still believe the immediacy of typing in a line of code and running right away is super important to capture modern programmers. And especially when debugging. I hate when I debug. I have to have type correct expressions before I can execute it. So that's good. So we think that this optional type system allows flexibility in a project. It gets out of the way when you do experimentation, and it was inspired by Strongtalk. I think you should, if you haven't tried Dart, sit down, try it out, and see if this flexibility actually helps you be a better programmer. So I have a few slides about different parts of Dart, and I'll talk about where we got the ideas from. It's not very technical, so bear with me. So Dart, the constructors in Dart are very simple, but we try to make them even simpler than in Java and C++ by eliminating the bodies of a constructor in most parts. And we introduce name constructors because we don't have type overloading, and then we also have factory constructors. I'll show a few examples of that. So name constructors allows us to have more than one constructors for one class. And here we have, again, the point class, and I've added another class constructor, point.polar, which take 2 arguments and compute a point based on radius and distance, and angle. And this is just how it is. And we had to put that in order to have different ways of creating new objects. The idea came from Craig Chambers, that said that we needed this in order to have it as flexible as other programming languages. So we put it in, and it actually worked really well. So many of the classes we have in our libraries provide several different constructors. As you can see, the first constructor, and even the second one, they don't have any body parts. So the first one, there's automatically this assignment to the fields, and the second one has an initializer list, just like in C++. We have factory constructors. That's basically constructors that lie about what's happening when you say new. In Java, as you probably remember, you always use a concrete class when you say new. So you say you have to have a new double linked list instance or what have you. And I think that's fairly complicated. In most cases, people, the programmers, especially the simple ones, they don't care what kind of list it is. They just want the list. So we provided this factory forwarding mechanism in Dart, so that you can just say new list, and you'll get the appropriate one defined by the library. And in the case of our current library, the list factory will return you a double linked list. Here's again an example where you can allocate a new instance without types and with types parameter. And here's an example how you can make a class that will canonicalize strings and return simple objects. And we have, again, two constructors. One that's called internal, that will just assign the string to the field. And then you have the factory symbol, the canonical one, that will give it a name, see if it's in the cache. If it's in the cache, it'll return the cached instance, otherwise it'll create a new one. One thing you'll see here, we're also using private names. Since we can run without any type checking, it's important that we know what's private at the use site, but also at the dev site. And so underbar in the beginning of a name will generate a unique key for the current library. And so we have library privacy in Dart. So outside the library symbol, the simple library, you cannot call the internal construction of a symbol. For those of you who have used Smalltalk, we have cascaded calls. And that's actually an easy way of invoking multiple methods on an object without relying on method chaining. You all know what method chaining is. That is when the methods always return this at the end, so you can chain the methods. And this is just inspired by Smalltalk. The only difference between the cascaded calls we have in Dart compared to Smalltalk is that you don't have to write yourself as the last one. So the expression will always return the receiver of this cascaded call. So here's an example. And it just makes it easier to write code where you want to do multiple things to the same object. So ... is a cascaded operation in Dart. I told you about the browser is very strange in that it can only run one thread. And we had this problem that code become unreadable because it's based on events coming in. So if you want to do any kind of I/O, right, you basically have to provide callbacks for each completion of the I/O. And that makes the code really hard to read. So we teamed up with experts in the area. So Eggman helped us design a way we can get around that by providing asynchronous methods in our platform. And you probably know that already from C#, and Hack also has it now, so it's pretty much the same. So if you have synchronous code, you can just write code on the right, where you have read operation and write operation, catch and finally and whatnot. And it's very easy to see what's happening. But these I/O operations, they're blocking. And if you have a browser where you cannot block, this is not what you can write in normal code. People, of course, say, why don't you just use multithreading? Well, we cannot do that in the browser. And multithreading is not always the solution to this problem, because multithreading is often expensive. If you look at Java and you run many threads in Java, it will suck up all the resources of the underlying platform. And even in Java nowadays, they have asynchronous I/O. So you put in this async methods in Dart, and I'll show you how we came to it. So the asynchronous callbacks are really a pain. If you don't have any special support in the language, you basically have to create a read-write method, and in the read method, you have to provide a closure they'll be executed when that read operation has completed, and that will then chain the events coming. And this case here, where there's only two following events, is not that complicated. But you can imagine if you have control flow that has to happen, then it becomes fairly complicated. And then there's an error handler you also have to pass along. And if you look at some, for instance, code from in JavaScript, you can see that you can often see these 10 nested levels of callbacks. And reading that is very complicated, at least for me. That's not a modern programmer. So having code like is on the right is much more readable and also easier to maintain than these callback hell. So we put in futures. That was the first step to make it better. So we had a future, and the only thing a future does is that when the operation completes, it fires. So you can add a closure to a future with a then operation, and when the future fires, then that closure will be executed. So that'll help a little bit. But it doesn't help you with control flow. It only helps you with this chaining. So we hired Eggman in our group to help do the design. He knew what he was talking about because he did it for C#. And luckily, our libraries in Dart they were already using futures and streams. So this was a very good fit for it. So we introduced async methods. And the good thing about these async methods is they were incremental to use. You can take one method at a time and convert them into being async. And this is how it looks. It doesn't look exactly like the synchronous code on the right, but on the left you can see that you mark a method with async, and then for each point here where you can be suspended, you put in a wait. So this is how code looks. The implementation of it is extremely complicated. So what you have to do, for each place where this async method can be suspended, you have to provide a continuation point. The way Eric calls it is a wait suspends the activation in a non-blocking way, which makes sense to some. So is it good to have these async methods? I'm torn here. The process, of course, you restore normal control flow when doing I/O in this single-threaded way without blocking the main thread. And you have incremental migration of code, which is fine. So if you do extensive I/O work, this actually helps a lot. But there's drawbacks. The drawback is that you get a programming language where you have a dual mode. You have to decide whether a method has to be synchronous, a normal way, or asynchronous. And it's sort of contagious. So if you have code where you start using a synchronous method, it has to be all the way. Stack traces disappear because these continuation points, they are activated spontaneously by the underlying system. And so you can often not see where you came from if you have a bug in that code. And debugging is still a very big challenge for us when we debug this code. So it takes a little bit away from the immediacy, but there's a need for it. But for the browser, we didn't have a better solution. We thought about putting in coroutines, but putting in coroutines that's translated to JavaScript is also complicated because you have to reify the execution stack of the normal stack, and that becomes slow. I'll just say a few words about fast startup of applications. We are still in the browser space, and JavaScript is slow to start up because when you read in a JavaScript program, you have to pass all the code from the beginning and set it up before you can run it. So big programs like Gmail and Docs and whatnot can take a second, for instance, to start up. And this is, in our minds, too slow. So we certainly got inspired from Smalltalk and Lisp systems with snapshots. And we designed the language so nothing happens before the first statement of main. Right? Remember JavaScript. you had to pass all the code before you could start executing. In Java, you have to do class initialization of many, many classes. Last time I checked, there was 206 classes you had to initialize before you can start executing main. But Dart has been created so that nothing happens before the first statement. We don't have eval in our system for security reasons. Eval is this way you can take a piece of string and evaluate it inside the current system. Because we don't put that in, we get a more secure system, and we also allow tree shaking. Tree shaking is a way where you can analyze the program and throw away the pieces you can prove you don't use anymore. That makes it smaller, and it makes it faster to start up the program. Last time I measured it, when you compared it to JavaScript and also starting Dart from source code, we can get a factor of 10 in performance startup by using this technique. So I think it's still a valid technique to start up programs. The snapshots are still platform independent, so they can run on different architecture. So it's not like that we store code in it. It's basically the same as Smalltalk. We start up a program without executing any code, and then we serialize the heap, and that is what we suck in afterwards. That makes it run really fast. Of course, we cannot do it when you translate to JavaScript. You have to run the Dart VM. Anyways, so that was the starting point. That was trying to make something better for big applications on the web. Dart is now put into an open standard, Eggman. And Gilad here has done most of that work. We got the first edition out in 2014. We added a few things like enumerations and asynchrony and deferred loading in the second edition. And the third edition that just came out here this summer, we have null-aware operators and generalized tear-offs. Small things, but it's improvements based on feedback from the community. So what happened since then? So when we started 5 years ago on this programming language, it was mostly for the browser. What happened in the meantime, that's the mobile phones. Suddenly everything is about what can run on the mobile phones. So we had to change the strategy. We're still doing stuff for the browser, but we want to expand out to mobile and also for the new IoT market. So I'll talk about these three areas a little bit. We're still doing Dart for web applications. We have dropped the idea of getting the Dart VM into Chrome because it's all about mobile, and if you add yet another VM into the Chrome browser on mobile, it'll be even bigger, and that's a problem on mobile. But we have improved the translation to JavaScript a lot, and the V8 is actually getting better and better, which is nice. So we get reasonable performance even though we translate to JavaScript. Working on better interop with JavaScript, it's not a trivial task. And then we are experimenting with a subset of Dart so we can generate better code. And then also adding generic methods. Some people actually want fully, they want to have more generics in the system, like in Java. And we'll probably get it to them at some point. Right, Gilad? The Dart for mobile is interesting. So there's a new project at Google, it's called Flora. It's a platform that does sort of jank-free 60 frames per second animation. And they started their project by doing simplifying Chrome and see how much they could simplify and get better performance. They ended up throwing all of it out, and it's now fully implemented in Dart, which is great. So this is really a Dart framework for having a really nice mobile setup. It works both on Android and iOS, and they have a fairly big group working on it, and it's currently in development. I think it's in alpha, but you can download it. It's open source and try it out. So we are excited about having a platform written completely in Dart. So that's the effort for mobile apps. And then we have started a new thing for IoT devices. I think we're all aware that this is coming now. We believe that Dart can add a boost to programmer productivity on embedded systems. Right now, most people are using C and assembly, and debugging is very, very tricky. And the turnaround cycles for updating a program, flashing it onto the device takes a long time. So we created a new VM. It's called the Flex VM. It's much smaller than the normal VM we have. Right now, it's only based on an interpreter. We'll probably add a small JIT to it later. But the big thing is that the memory footprint is very small, and we can run in a few hundred kilobytes of RAM. So the current target for this Flex VM and Dart is this microcontroller. It's a 32-bit ARM, 320 kilobytes of RAM, and a little bit of flash. So that should be sufficient to run a good Dart program. Right now we have this Flex SDK available running on Raspberry 2, which is fairly big. But you can click on the link if you can try that out and download and see what it is. It's still in pre-release, but it's fairly exciting to get Dart running on very small systems. One thing that's really cool about this is that we have a setup where we have a development environment that's always running. So what you have on the device is only the tree shaking part that's actually needed for the execution. So if you want to evaluate an expression on the device, it will analyze what's the code more you need on the device before it can run it. It will be downloaded into the IoT device and then being executed. So we're trying to keep the runtime as small as possible, and when you're done doing the development, we will be based on a snapshot and just run the minimal code on the device. So here's a long road for Dart. We started with Spot in year 2010. We did the design, spent at least a year doing it, implemented libraries for the web, got it to run on the web, and we shipped the first public SDK 1.0 in 13. And we sent out a number of releases. I don't remember what the current one is. 1.13? Okay. And we are now working on web, mobile, and IoT for Dart. So it's a long way. In the old days when I did virtual machines, it was easier to do black box replacement. Make something that was faster and smaller, everybody liked it. The surface area of a programming language is so big that you'll get a lot of interesting feedback from the public, whether they like it or not. But it'll be interesting to see over the next few years how it'll go. It's very hard to tell whether it'll be a total success or not. I think it looks pretty good now. We have many big projects at Google using Dart, and I think that'll be a driver for seeing whether it'll be a mainstream programming language. We have an official dev process, which is called the Dart, stands for the Dart development process. And right now we have sort of 4 big proposals in the pipeline. We're investigating non-nullable types by Patrice Chalin. And this is a complicated one because it has a pervasive impact on libraries and everything. It is really, really cool. I like it a lot, but we have to make sure that we don't destroy the baby in the process. The idea is that by default, all types will be non-nullable, and you have to put a question mark after it to denote that it can also be null. There's generic methods, still not determined yet, better support for islets, and then we have configuration-specific imports so that you can have platform-independent APIs and then platform-independent implementations. So we are taking it slow to make sure we do it right. There's a lot of proposals people want to suggest and get in. But the fact is that whenever you have a simple proposal, it has an impact across the whole programming language, and it takes several months to figure out what the impact is. Often we have to do a prototype implementation and see what the impact is on the programs you have. So sometimes I'm asked, what are the regrets for Dart? Well, I think the focusing too much on the web has been a problem. And that de-emphasized the work on islets and parallel execution because we couldn't do that in the web browser. It's now being opened up because now we also want to run on mobile on IoT, and that's where it's important to run many islets on the same device. Also, one regret, a small one, in Dart we have implicit closure tear-off inherited from JavaScript. And it's basically, if you look at this example, it's about often when you want to execute toString on an object, you say toString and parens, and that will execute the method. If you forget the parens, right, it will tear off a closure that captures the receiver and whatnot. I was told that people do not make mistakes by omitting the parentheses. I should have been more firm because this is actually surprising to most people, because we also have accessing of fields where you don't provide the parentheses. So you have polymorphism. So if you ask one object for X, you'll get a field. If you ask another one, you'll get a closure, and that's not often what you want. So we have this proposal it's already in, where you have a specific syntax for explicitly extracting the closure, and hopefully we can move to that so all the code will use it. There are still areas we would like to explore in Dart, and maybe some of you can help us do it. One is to see whether it's useful to have a plugger, more addition to the type checker in Dart. We have done some, but we are right now putting in an infrastructure so you can plug in your own type checker for Dart. And since the types do not affect runtime, you can have your own customized type checker that will flag certain problems in your program. Another one is how to split up applications into islets. Islets in Dart are independent executions, have their own heap. So if one heap dies, the other ones will go. It's like Erlang. And all communication between islets will happen with message passing. What we want to make sure that we can pass immutable objects without any cost between these islets if the islets are running on the same machine. So we are right now trying to figure out how that works. Dart is completely open source. I don't know if I mentioned that. And we have researchers working on the source code. But please take a look at it. Everything we do is fully open. We do commits every day. And that's how a programming language should be done these days. Please create more programming languages. They're important for innovation. There's two problems I see with it, though. Is that industry and academia, they're both fairly conservative when it comes to programming languages. I often see universities use Java as the only programming language. That's just sad. I like to see bold professors using sort of strange programming language, and many of them, because that will certainly teach programmers to adapt to a new programming language very quickly. The second one is, and we had that discussion yesterday at the Future of Programmers panel. We talked about religious views on programming language, especially when it comes to the web. We have seen a lot of JavaScript programmers being very unhappy with Dart because we are trying to replace JavaScript or make something different, because JavaScript should be the only programming language for the web. I'm of a different opinion. We need more programming languages so we can see how we can improve the productivity of programmers. So I'm almost done, and we can take questions. I hope I can have convinced you that we actually spent some time doing a proper object-oriented programming language, where we thought about readability of the program, it being well-defined and nice, and also it'll be better for program productivity of certain projects, and also it has nice system properties. It can run fast, and it can start up fast. We have already had some project success with Dart inside Google, where they have at least claimed, it's hard to measure, that they have been faster at completing their project using Dart, which is nice. I hope that some researchers could figure out a way how to measure productivity in a better way, but we have to trust them on what they say. Only time will tell whether this become a real mainstream programming language. If you look at how many programming languages have been designed over the years, it's hundreds and hundreds and hundreds. Most of them fail. I think even after 5 years, we still have a chance. Whether it will become great, we'll have to wait 2 or 3 more years to figure out. And that is my talk, and I would like to take questions now.
Hi. I have 2 short questions. One is, when you create a new language, you